I made this. How did I do it? I'll show you. The Vorpal Robotics Hexapod. I backed it on Kickstarter after seeing it on Thingiverse about half a year ago, and I'm pretty pleased with the results. This model you see in front of you is the Complete Deluxe Maker's Kit. It goes for about $220 US on the Vorpal Robotics website. What does that mean? Well, it means that it comes with all of the 3D printed parts and the electronics, and you use the freely available instructions to put it all together. If that sounds a little bit too hard for you, well, you're watching the wrong video, but you can pay close to $300 to get one that is fully tested and assembled and comes to you working right out of the box. If you own a 3D printer, however, you'll find that there's a cheaper version, the cheapest being about $140, where you can print their own parts, just get the electronics from them and put the whole lot together. They claim in the instructions the only thing you need is some sort of permanent marker on top of the supplied Allen key. There are quite a lot of parts, but as you'll see in this video, it's really not too bad. Let's start. Linked in the video description is the Vorpal Robotics wiki. On here you'll find all the instructions that I followed and based this guide on to put your robot together. Although I have varied from these instructions a little bit, you'll find that it's mostly the same. The wiring diagrams are essential. We're going to start with the MG90S servo bag, and step one of the instructions is to make sure that none of the servos are seized. It actually comes with a spare, which is super helpful. And we're going to open up one of the bags of servo horns, and we're going to get out just one of the single-sided horns. And our opening procedure is to go through each one and to make sure that none of them are stuck. So we simply clip it on and we very gently work it back and forth until it releases, just like that. Take it through its range of motion and move on to the next one. Next thing is we're going to take our permanent marker. It needs to be white or silver so you can actually draw on the black plastic connectors. We're going to pick our best 12 servos. I had one that was a little bit stuck, so I put it aside. And then we're going to write 0 through to 11. Alright, once you've done that, we're finished with our marker. You'll notice on the lid that the servos are numbered 0, 1, 2, 3, 4. And when you do the knees, the rest of them will be numbered there too. So let's take our servos and match them up. We're only going to need 6 at this stage. Turn the chassis upside down and you'll note the space for the servos. There is a round cutout that matches the servo. So that means that the round bulging part of the servo is towards the outside. Once you've clipped it in, take the wire and feed it through the top port, which is right next to it. And now repeat for the other 5. And you'll notice here we have the accessory port. This part counts as the front of the robot, and there's some hardware that we need to add to it. From your parts collection, you'll need to get out the hex head bolts, and there's 2 long ones, 2 short ones, 4 nuts, 2 wing nuts, and our Allen key we can also put aside because we're going to need that soon. On the inside of the chassis is 4 3D printed hex cutouts. We're going to put the bolts in from the inside with the longer ones at the bottom, which means towards the floor. Working back on the outside of the chassis, we take the 4 hexagon nuts and we put them on finger tight and then tighten them slightly with the pliers. We then take the wing nuts and we put them on only finger tight onto the bottom 2 longer bolts. These will be used later on to retain accessories and expansions. It's time to put our chassis aside for a little while, but also get out our 6 feet, our legs that we need, and we need back our 6 servos. And what we need to do is match up the number we wrote on the plug to the numbers on the leg. So in this case I'm looking for 11, and of course it's probably going to be the last one, second last one that I need. And you can see there's the cutout there that's going to match the final position of the servo. So once again I'm just going to wiggle, let it flex a little bit, and with a satisfying click it goes into place. Alright, our servos are on our legs and we're going to deviate from the official instructions and put together our knee joints. You have 12 identical pieces like this, and it doesn't matter which ones you pair up at this stage. Only thing you need to pay important attention to is the dot on there. We want to turn them around so the two dots are next to each other, and these are designed to flex. So if we flex them open just enough, we can get them to clip on, and the two dots will be next to each other, and the parts will go together without breaking. So repeat that to make 6 joints. Okay, now that we have our 12 joints together, the reason for us deviating becomes apparent. In the hexapod, all of the joints sit in place like this, but unless we put the joints together at this stage, we can't take advantage of this little hole here, which is a really tidy way to run the wiring through. So it doesn't matter which one you match it up with, and you don't even need to clip it in place at this stage, but for each one, just orientate it so the cord lines up with the hole and run it through. So we've got all of our legs ready to go, and our mess of wires inside the chassis is about to get a lot worse because we're going to thread through another 6. We take our legs and we notice there's 2 numbers on there, number 1 and number 7. So the second number is always 6 added to the first one, and we rotate our chassis until we match up the number. So here's number 1 matching with number 1, and we'll find a second port there. Let's run the wire through, and we pull it through, and we leave it sitting roughly in place, just like that. Looks like we've got most of Hexapod in front of us, but the hard work is about to begin as we wire up the electronics. Before we can put the little horns on the servo, we need to have the electronics wired up because there's some modes inbuilt that will help switch them to the right angle so we know which way to put on the horn before we put the legs together properly. So let's get started on that. First part we need from our electronics is the potentiometer. So it's the one with a dial that can spin around, and what we're going to do is to pull the cap off. It's just a squeeze fit. There's also a nut that we're going to twist off. And then locate on the robot, there is a hole and another little hole next to it, and then some markings around the outside. This is where the potentiometer is going to go. So there's a little piece on here that sticks out that we're going to line up with that second hole, and to make it work we just need to bend the wires just a little bit. Keep bending those wires just a fraction. And then it slips in from behind, and we can put the nut on as tight as we can get it. I found by hand was easily tight enough. On our potentiometer, we're going to turn it the whole way counterclockwise until it stops, and then get our knob and the bit that points in a certain direction, we're going to put it on so it's pointing towards stop. That's the default position for this part. Okay, next up comes the switch. We're going to need the battery holder and the other components with the BEC included. And we take this switch and we have a small 3D printed part that we're going to slip around the wiring for the switch. Like so. Doesn't matter which way it faces. Switch pops into there. Shouldn't be too hard to achieve. Make sure you don't have any wires caught. You don't want to rip any off. That's going to give you a bad day. And then rotate the chassis around until near the potentiometer you find the on-off switch. It's got a 0 and a 1. We simply have to match that up, push it through from behind, and we're ready to insert the screws. Okay, in the screw bag there are some larger screws. They've got a domed, almost mushroom-like head, and that's what we're going to use to secure this switch from the inside. So we finally get to use our trusty Allen key. And what they recommend, and I would too, is to put some fingers behind the switch and apply pressure to it as you start to put in these screws. Now these screws, there's no thread on the printed part, so you've got to be making your own thread as you go. So it's going to be fairly hard to turn for the first few turns. You've got to keep everything nice and straight and aligned until the screw starts to dig into the plastic. Once you've got a few turns on one, get the other one into position. And once again, some light pressure from the back of the switch. We'll start turning it. It's going to be quite difficult. Okay, time for probably the hardest part. Everything you need to wire up the electronics is in Hexapod parts bag, apart from the Bluetooth module, which is in the gamepad parts button. And you'll notice they look identical, except they've already been pre-paired, and we want the one that doesn't have the M on it. M is for the master that goes in the remote control, therefore the other one is the slave, and it goes in the actual robot. So we'll put this one aside for now, and we'll get out everything else. Okay, we have all of the parts left out from left to right. We have the Bluetooth module, we have the controller board for the stepper motors, we have the Arduino Nano, which is the brain of the robot, and that's marked R for robot. We have the buzzer, we have these 20 centimeter longer cables, and then we have these collections of ribbon cables for the other connections. These wires, it doesn't actually matter which ones you use. However, you should follow some conventions, which dictates that red or orange is for positive and brown and black are for negative. The really long ones, we're going to keep those to go out the accessory port at the front of the robot. And apart from that, probably the easiest thing to start with would be all of the numbered connectors, which are going to go into the stepper motor controller board. So we can take these, and you'll notice that they are numbered 0 on one side through to 15 on the other. And we can use that to plug in all of these stepper motor drivers. We have wired up all of the stepper motors to the stepper motor driver board, and we're ready to proceed with the instructions for the Nano. It's important just to follow the instructions one pin at a time, using black or brown for negative and orange or red for positive, and double check everything before you proceed. Let's go. Okay, so I've finished one side of the Nano. You can see here we have ground RxTX to the Bluetooth, we have the signal to the buzzer, and then a gap, and we have blue and green 20 centimeter long wires to go to the accessories port. Let's do the other side. The second side of the Nano has been wired up. From the top we have the red positive and black negative from the battery, the single connectors, and then from there we have red going to the positive of the 5 volt. Then we have the long 20 centimeter purple jumper going to the accessory port. We have servo controller SCL, servo controller SDA, 20 centimeter yellow jumper. There's a 3-pin connector coming from the potentiometer that goes perfectly into there. Okay, so the next steps are to take a spare orange and brown or red and black wire and run them from the negative and the positive of the buzzer through to the positive and negative provided by number 13 on the servo controller. And then we find in our kit there should be a connector that's 3 wide but with only 2 wires going in, and that's going to go into port 12 of the servo controller, and that comes straight from the BEC and provides power to the servo controller. From there, the spare pins that aren't used are going to come out into other things like the accessories port. We're almost done. So on pin 14 we have a 20 centimeter orange and brown, and we have a white, red and black for pin 15 of the servo controller. And all our wiring is finished. We should have all of the long ones used except grey, and we can pull those kind of together and out of the way. And the good news is, if you've connected all of that in and double checked it, it's time to turn on the robot. I have inserted 2 batteries, I've made sure the switch is off, and I have made sure the potentiometer is put in the stop position. At this point, we're ready to turn on the robot for the first time. And we're listening for 2 beeps, and we want to see the servos go to their correct position. Okay, seems like a success. I've just finished the very tedious job of getting all of the single-sided servo horns out of the bag, and we're ready to put them on. It's a little bit tricky. We need to switch on the robot, wait for the 2 beeps, And then we take the potentiometer and we have to move it from the stop very slowly till we get to the adjust position. This will flex all of the servos into their 90-degree position. So what we do is we get a servo, we observe there's the round part and then the bump, and we put the horn on facing exactly away from that bump. For the actual hexapod, we do the same thing. This means that they face 90 degrees out. Okay, now we have a fun job. Most of the hard jobs on the hexapod are finished, so it's time to connect up the various knee and leg joints. To do this, we'll notice there is a cutout for the servo inside each joint. What I would recommend doing is putting in that side first, and then very carefully flexing the knee joint out until it clips into place. You may optionally wish to get the Allen key and just push it against the servo horn to make sure it's sitting in nice and flat. I do have the robot turned off for this stage because you want to be able to flex it just a little bit and make sure that it's working. Very similar for attaching the hip joints. We line it up with the servo horn, put it in the servo horn side, and then squeeze over, make sure it works, and move on to the next one. I've assembled all of my legs and we're ready to do something very exciting, which is turn the robot on and see if it can stand up. So I will put the potentiometer all the way back to stop, and then I'll turn on the switch, wait for the startup procedure, and put it on the ground and see if it can support its own weight. What we're looking for is for every leg to be touching the ground. We can see here number 3 and 0 aren't quite touching the ground. So we're going to do a very quick adjustment on those. We're going to turn off the robot. We're going to lever them out. We're going to pull off the servo horn and move it 1 tooth of rotation. Pop it back into place. Fortunately, they've designed it so it's very quick to do this. Pop this one out. Move 1 tooth. Flex it into place, make sure it's seated, and repeat the test. Success! All 6 legs touching the ground. Time to continue. We've extracted the smaller screws out of the bag. One of the impressive things about this kit is so few screws are needed to put it together. And what we're going to do, if we're happy with the positions of the servos, is to insert them into each servo, into the top of the servo horn. So it's on the side of the knee and the underside of the hip. It should be pretty straightforward and easy to do. Now that the servo bolts are in, it's time to have some more fun. So what we're going to do is put it back to the stop position, turn on the robot, and we'll keep turning it around, past the adjust one, and then to the test. And this will go through every joint one at a time. You want to check that all the hips are working, and then all of the knees, which they are, which means we can have the real fun. And it's time to put it all the way up to the top for demo. ready to continue. Okay, time to give this robot a much needed makeover. So you should be able to find the electronics caddy and 2 retaining clips that look exactly the same. We're going to turn them over so the bits that stick out face towards it, and we're going to squeeze the ends and slide it into place. We're once again looking for that satisfying click. There we go. And we're ready to install our electronics. For now, we're going to pull everything out of the robot, and we might start with the buzzer. You'll notice on one side of the robot there's a little hole here that is designed for the buzzer. That's its home. The little lever on the inside is going to be somewhat fragile, so if it snaps as you push the buzzer in, it's not the end of the world. Okay, beautiful. The buzzer is in place. Next, we're going to get all of the 20 centimeter long accessory wires, and we're going to find the mouth of the robot, which is the front, and we're going to poke them through here to keep them out of the way. Like so. We now take our electronics caddy, and this one's pretty hard to go wrong. We have 2 slots that match the widths of the components that are meant to go inside. The first one is the stepper motor controller. That's the one in the center. It's a little bit wider than the other one, and we simply slide it in, and that little raised bar goes down the middle of the board. And then next to that we get the nano. Slide it into place as far down as it goes. We turn it over. On the back side we have room for the Bluetooth module, which we untangle. And this one I probably found the tightest for the cords. It faces outwards so you can see the LED. Going to feed it through this hole. I find it's easier to temporarily unplug, but hold on to all the wires. And then it goes on the middle 4 pins in the same order if you haven't let go of them. Okay, that's quite nice there. Everything should be out of the way except for the battery, which sits on top in this area here. One thing I would advise is you have this little hole here. I'd suggest making a little slot because there's not actually anywhere for the battery wires to go around. So I'm going to do that now and then use 2 of my screws to screw it down into place. Okay, so everything is now neat and tidy. The robot is looking much, much better. I have carefully put in the screws, cutting the threads as I go on the top, and you'll notice I've just bent the Bluetooth pin slightly out of the way to make enough clearance for the lid. Very important to check that nothing has come loose as you put everything in, so put the robot in the stop position, turn it on, hopefully it comes to life. Excellent. We have 2 very minor things left to finish the robot. Firstly, we have the cap, and in the pack there should be 8 magnets. We're going to take those magnets and one at a time clip them with the little dimpled side facing out. That's the north pole of the magnet. The fit on these was really good for mine, so it should be quite easy to get them into place. The other thing is to get out our stickers, and on the underside of the robot affix the warning label. And the robot is just about complete. G'day, it's Michael again. If you like the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.